שקט, אצא לחלום לראות, נביט אל השמיים, נחכה ביחד ליונה. Hello darkness, my old friend.
Good evening. Tonight, we have gathered for the 7th consecutive year to celebrate 3 of Israel's most promising young researchers and present our laureates with the 2024 Blavatnik Awards for young scientists in Israel for their work and discoveries in their respective fields.
The vision that was planted in my brain still remains.
Winning a Blavatnik Award is not only a sign of extraordinary scientific excellence at a young age, has become something to strive for, a lofty goal that excellent young scientists aspire to reach. And indeed, looking through the list of past Blavatnik Award laureates, one is struck by the amazing quality of their achievements, both before and after winning the prize. They all continue to exhibit impressive scientific leadership, making new and surprising discoveries and inspiring their colleagues and students worldwide.
Now more than ever, the world needs science and it needs the work of our scientists. Even, and I would say especially, in the midst of severe geopolitical tensions, we need to remember that the work of science not only transcends politics, but it is critical for creating a better world for us all.
Significant technological advances over the past decades, what we recall the resolution revolution, have meant that we could gradually obtain better and better resolutions, better and better details using the microscope. And today, the 3D objects that we obtain actually look like this. So we can simply use this method, we can simply use the electron microscope in order to look at protein. So for the first time, we had an explanation why these mutations are associated with obesity. Now, this may seem like a small discovery, but this kind of insight is the information we really need to identify drugs or treatments to address all kinds of genetic mutations that are associated with hunger.
I'm a theorist. I don't build computers. Instead, I try to predict what they can be used for. I work with equations that describe quantum mechanical effects, and my goal is to understand how these equations can be used to improve the way we do computation. So the key player in my research is entanglement. And the question I ask is, how does entanglement affect computation? What I would like to show you in this presentation is how asking and finding answers to this question leads to insights that cross boundaries between fundamental physics, computer science, and abstract mathematics. All these areas of science unite to understand a single phenomenon.
Without knowing where a modification takes place, we are severely limited in understanding what purpose a modification serves and how its disruption can manifest in disease. Our lab took a multimodal approach, combining computation, chemical, and biological methodologies to develop a suite of approaches, each geared towards mapping a different RNA modification and at what positions. With these approaches in hand, we could chart the universe of RNA modifications. So what did we discover? I will briefly share with you 2 highlights. A first story is about the most abundant modification in human mRNA called M6A. Remarkably, we found that its distribution across different RNAs determines the lifespan of the RNAs. A heavily modified RNA will have a very short lifespan, whereas one with fewer modifications will have a much longer lifespan, which in turn affects the number of proteins each of these will produce. This is important because the number of proteins within a cell can control whether a cell will adequately respond to an internal stress or an external threat like a virus or an immune attack.
To science, l'chaim.